the subject. Today, with your constant guidance, with your great contribution, Dr. Gupta, we've been able to reach a day where we are organizing the fourth in the series of OTPs, and with a very suitable theme. And I congratulate you for advising us and compliment you for suggesting this particular thing, which is industrial safety, planning and management. One of the key, it sounds very basic, but one of the key areas which will be covered in these 3 days. Over to you, Professor Gupta. Before we formally start, a few comments from you, sir.
Thank you, Rubabji, and respected General Bhardwaj Saab, who has been the kind of a backbone of this initiative, and Major General Manoj Kumar Bindal, ED and IDM, both General Bhardwaj has joined, or he'll be
joining any moment. Very soon he'll be joining.
Okay, yes. Okay. So I express the gratitude to both of them in absentia. They will be joining us shortly. I compliment the team, CIDM and FICCI team, Mr. Ruab, Akhil, Sanjeev, Varun, and other colleagues from FICCI, and from NIDM side, my colleagues, Dr. Anjali and Mr. Harshit, and all the resource persons, because this is a big team. In fact, Manak is smiling. Manak has been very instrumental in many of the initiatives earlier also. So I'm happy that our team is also growing. As Rubab was referring to, that this is the fourth OTP in the series. So each and every topic, when we theme that we choose for the training program, then we also associate significant experts who are having national and international expertise. So that this is also strategically important, that we are strengthening a very important team on various dimensions of chemical industrial disaster management, and by the way of these OTPs and a series of webinars, I think we could reach to more than 10,000 participants and across the country over past 4 or 5 months. So this cooperation between FICCI and IDM is going a long way, and has to go a long way, because the subject of industrial chemical disaster management, which has, I would say, got a little kind of some weakness in the pace. And now with our joining hands, and with the support of industry, because after a few incidences that took place during this coronavirus lockdown phase, and when the industry started after the lockdown, the awakening is great, and people themselves, the industry members, and the senior authorities of industries, and the professionals working within the industry and for the industry, they have taken this matter very seriously, that industrial accident management and industrial disaster risk management is a very important dimension, which has both technical as well as managerial dimensions, which are important. And that is why we thought that after a series of 3 training programs, where we covered technical dimensions as well as the legal and regulatory framework also, the previous one was that on that, how to use this both knowledge, technical knowledge of risk management, as well as when we have a regulatory framework. So how we put both in a blended form into practice. For that, actually, we require prudent planning, and this prudent planning or effective planning in the form of this that starts, in fact, from the design stage itself, and then we have designated the kind of plans also. For example, on-site emergency plan, off-site emergency plan. But beside this, Disaster management plan is also an integral component of EIA and EMP, and also within the government system we have disaster risk assessment as a part of the project appraisal process. So that is very interesting. So how to look at multidisciplinary angle of this planning and management issues of industrial safety in within the industry. And when we say industry, it is again a vast gamut, from the investment point of view, from the physical extent point of view, but also the type of activities involved. So whether it's process industry, manufacturing, construction, mining. So a range of industries are there, and each and every type of industry would require a different set. So
Hmm.
this program will be focusing on health, occupational health dimensions, risk assessment, auditing also it will touch. So several important dimensions will be touched upon in this course. I'm very happy over this development, and I shall look forth at the successful conduct of this program. Thank you, and over to you, Rubab, again.
Thank you so much, Professor Gupta, for setting the perspective and giving all the participants who've joined us the very relevant background of industrial safety and how important it is in today's time. And it could not have been a better time for us to discuss this subject when we are not only going through a challenging COVID crisis, but moving on, looking forward. I think the industrialization has only one path to follow, which is of growth. And when we are post even during COVID time, the level of industrialization which will India is one of those countries which is looking forward to faster growth in industries and industrialization post COVID phase, because of the opportunities which our ecosystem provides to industry, not only in India but for foreign players as well. So, and in fact, very interestingly, I would like to share it with all the participants who have joined us that during recent JKML lecture at IIT Roorkee, and the inaugural lecture was given by none other than Dr. P.K. Mishra, who's the Principal Secretary to the Honorable Prime Minister. And he talked about black swan events, and one of the things which he mentioned while talking about COVID was chemical incidents and chemical disasters. Out of the four major issues which he brought up, so the leadership also is looking into this subject with utmost seriousness, utmost relevance, and I am sure these small steps which we are taking in that direction of building and improving capacities among industries will be well noted by the not only the leadership but by the concerned ministries and departments. And it has happened that over the last 7-8 months, the kind of support we have received from the concerned ministries and departments has been overwhelming. Starting from, I'm sure NIDM, and that has definitely enhanced the entire, partnership model, of CIDM. But we are really proud to be associated, and I think we are just making those small steps of
Yeah.
building a better system, better ecosystem, safer ecosystem in the country for industries to operate and for the workforce to work. Uh, on that note, I think General Bhardwaj is on a call from NDMA. I think there was some urgent discussion which the secretary is having with him. So General Bhardwaj will join us. My colleague Varun is following up with him, is in close touch with him. So
Okay.
without taking any more time, sir, I think we can formally, we have already touched the 300 mark, sir. So we are at
Yeah.
298. So thank you so much. I think to all the participants.
I think Rubab got some technical trouble. Sanjeev, you can take over.
Good
Sanjeev?
afternoon. Yeah, good afternoon, sir. Actually,
Uh,
yeah, Rubab is
yeah,
back. Rubab is back.
back. Yes.
Yeah.
Yeah, this time he is back with the
Video also. Yeah.
video. Great,
So,
great.
yeah, Rubab, your voice is not coming. Please unmute yourself. Voice.
Rubab, your voice is not coming. I think he's still facing some trouble. So Sanjeev, you can invite
Yeah.
the next dignitary. We can move ahead.
I'm just checking with Rubab for a minute only, and then if
Okay.
yeah.
All right. Please check.
हाँ, आपकी आवाज नहीं आ रही है, आपका वीडियो आ रहा है, तो आप प्लीज स्टार्ट करिए, आइए वीडियो करके। अब जन भारद्वाज सर भी आ गए हैं। भारद्वाज सर भी आ गए हैं। ठीक है, हम
भारद्वाज
बोलते
सर, नमस्कार, वेलकम भारद्वाज सर।
हम अनम्यूट करवाते हैं चंदन से। आप इस पे आइए, स्टार्ट करिए। अनिल गुप्ता सर कह रहे हैं स्टार्ट करने बोल रहे हैं।
भारद्वाज सर आ गए हैं। भारद्वाज सर
हाँ सर, रुबाब भी आ रहे हैं, सॉर्टेड आउट, सो ही इज जस्ट
ठीक
ज्वाइनिंग बैक।
ठीक है, कोई बात नहीं।
भारद्वाज सर भी आ गए हैं। हाँ,
Hello, can you hear me now?
यस सर,
यस सर, यस
नमस्कार
सर।
सर एंड वेलकम सर।
Namaskar ji. Namaskar ji. Namaskar ji. How are you all? Good afternoon. I had some technical difficulties in joining, though I was trying to join at
जी सर।
2:25, but I don't know. Host has muted me and also disabled me as far the video is concerned. Anyway, all is well that ends well. So I have joined the a good meeting
Sir.
starting today.
Sir.
So Gupta ji, you have finished?
Yes sir, yes sir.
And Rubab?
Yes sir. Rubab has been coordinating, sir. He now got some technical issue. So sir, Sanjeev, you can welcome sir. You can request sir.
Rubab is back.
Rubab is back.
Very good afternoon, General Bhardwaj. Thank you so much for joining.
Yes, I can hear you. Rubab, you are not audible. Something wrong with your...
Rubab is also facing some technical difficulty. संजीव जी, आप सर को रिक्वेस्ट करिए।
हाँ सर, ठीक है।
Anyway, I don't require any formal
yes,
introduction.
Yes, sir. You are the backbone of this initiative. So, yes, sir. So your blessings are always important for all of us, and all the participants are also eager to listen to your.
Thank you so much. I'm equally very happy to join this fourth training program with the NIDM, and the NIDM with joining hands with FICCI. This platform, CID platform, is doing wonderful job during the time of COVID, and thanks to General Bindal and Professor Anil Gupta, that they've been very active during this period, and so our listeners also must be thinking that NIDM is so active as it has always been there. Now today's meeting, this 3 days program, is focuses very important topics, as you all know. We have not covered earlier the health part, so very important lecture on the medical preparedness and on the occupational health, in addition to the safety issue. Now, biggest today concern that we noticed in the chemical industry during COVID was the safety issue. And safety, whenever there is no safety, it results into lots of problems, including the health matters. And even now, the NDMA has started reviewing the national guidelines which we issued in 2007, whether they require certain importance of laying further stress on safety issues and medical preparedness. Medical preparedness, of course, was a comprehensive part for the chemical industry also. But I think general guidelines which we laid down in 2007 probably do require a little revision, and we will be doing it very soon. Already a panel has been established, and CIDM forum is participating in that. Of course, NIDM must be the core person to also address that. And once the new guidelines come, there will be certainly improvement over the guidelines that we issued in 2007 from NDMA. I wish great success for this conference today, and I am very sure that this will continue. The training programs for chemical industry will continue, not only on safety issues but other issues, planning and
Yes,
uh,
sir.
rehabilitation and resettlement. And you see, there's another issue with the chemical industry is the uh, general insurance part and making up the losses of the industry. Uh,
Yes,
those
sir.
issues have to be also covered in the national guidelines, how to go about it, because most of the industry, maximum industries in our country, especially the MAH units, are in the private sector, and therefore we must address something from the government side, that how do we deal with a major disaster when there is big loss to the industry and to the people. So what should be the mechanism? I also have noticed that though the national guidelines stand and various instructions from NDMA and IDM, they are issued from time to time, but there is a lack. What I felt was the preparation of SOPs on various issues in the industry, and follow up on those SOPs for not only safety but for each action, and also contemplating abnormal situations like COVID, because we never thought that COVID will come and sudden lockout will take place, and we will not be able to attend, how to store the gases and all those things, uh, when normally it is being constantly done under low temperature. And if you shut down an industry and every person disappears from the site, then it's difficult to sort that out. So those kind of SOPs are further necessary in that case. You all know the chemical energy is huge subject, in addition to the transportation and SCAMs and various type of changing scenario now. Safer chemicals are being advocated in place of the older ones. So I think lots of issues are there, and that these training programs can address those issues. I'm very thankful to Rubab and Party, who are part of my CIDM team, and they've been very active. And actually, they get restless when there was gap in between of not holding the conferences. I mean, the training programs and conferences as we used to have every quarter or so previously. But anyway, the good time will again come, and we'll have physical conferences being held in future also. I wish this training program a great success, and I'm very sure all the participants are going to gain a lot. Jai Hind. Thank you.
Thank you, sir.
Thank you so much, General Bhardwaj. I hope I'm audible now, Sanjeev.
Yes, yes.
Yes. Thank you so much, General Bhardwaj, for all your blessings, your guidance, your support, and your leadership, most importantly, in helping us drive the CIDM initiative all the way, and also collaborating with renowned institutes like NIDM, getting into a partnership of which is of great significance and of national importance, and something what we have proved under your leadership in the last 7 to 8 months. Your constant dialogue with the ED NIDM, General Bindal, on the subject of promoting industrial safety in the country has been, main guiding source for the entire CIDM team. And also, I'm sure Professor Gupta will echo the same opinion. I'm sure this is just a beginning, sir, and we'll continue working on the path which you have set for us. And under your guidance, we'll try and make whatever contribution we can under this partnership of making industries safer and the operations safer in this country, along with the workforce. Thank you so much, General Bhardwaj, for your very inspiring and motivating address, sir. Thank you so much.
Thank you.
Thank you.
Sir, I think due to some personal exigency, General Bindal had to he could not be seen here. But I'm sure on his behalf, Professor Gupta would like to make a comment, sir. Over to you, Professor Gupta.
Yeah, Major General Bindal, he was very much keen to join this program, but he has some unavoidable work at home, so he could not join. But he has conveyed his personal regards to General Bhardwaj sir and all the resource persons, and best wishes to the team. And he will join some of the day as per the convenience. So, thank you very much, General Bhardwaj sir, for always being a guiding force for all of us and blessing this initiative of cooperation between CIDM, FICCI, and NIDM. And your kind words are always the source of energy for all of us. And being the main architect of the national guidelines on chemical industrial disaster management. So just to inform you that now we are starting to develop a national disaster management plan for Ministry of Environment and Forests also. So the initiative that you had set for developing a national action plan on chemical disaster management, so that is also being worked out. And this experience of these joint programs between FICCI and IDM and CIDM, the issues which are emerging from these training programs and webinars. So those are also very important insights for that kind of planning process also, and improving those planning process. As we all are aware that it is likely that the issues of industrial chemical safety will be transferred to the Ministry of Chemicals and Fertilizers, Department of Chemicals and Petrochemicals. So that transition also we are witnessing. But whether it is with Ministry of Environment or whether it is with Ministry of Chemicals, all the ministries are open to collaborate and work with us. So that is a kind of a indication of the importance of the subject being realized within the government, within the industry, and within the set of professional institutions like FICCI is also collaborating with us also, and a number of top academic institutions in the country, for example, including IITs, ISM, medical institutions. So this is really developing a kind of a consortium. So that is a very good initiative. And with this, I welcome all the resource persons and all the participants once again. And I hope that this program would be of significant contributions to all of us. Thank you.
Thank you so much, Professor Gupta, for your comments and for your address on behalf of. I'm sure you echo the views of Major General M.K. Bindal, who's been a great source of inspiration and motivation for this entire partnership. I think moving on, I would quickly, before I request you for your lead lecture, Professor Gupta, I would just like to share with all the participants. Now we have almost 315 number, that we as organizers will be issuing a certificate, a joint certificate by NIDM and FICCI, and the for all the participants who attend all the 3 days of the training program, online training program, along with the presentations which are being presented or delivered during these 3 days. A copy of that presentations will also be shared with these participants. It is mandatory for all the participants to attend all 3 days of the OTP program to be eligible for a certificate which would be jointly issued by NIDM and FICCI CIDM both. As I request now Professor Anil Kumar for his lead lecture, I would just like to set the perspective from a very industry's point of view, that in a day and age where people still get injured on job, you would think safety would be a banner held high by everyone, but unfortunately it isn't up there on the priority for industries in certain cases. Money and apathy seem to be the two leading reasons why safety sometimes takes the back seat. The importance of workplace safety can't be stressed enough. So putting safety in the driver's seat is a winning proposition for everybody, for certain reasons, which includes that it's, industrial safety and measures taken in this area not only avoids injury and death or financial loss, it also helps save property damage. And proper industrial safety training, which is disseminated, can lead to productivity increase, service or quality of the product also improves, and most importantly, one of the very important things which the management needs to look into is that it improves the corporate reputation and the public relation also. So we have great minds and great experts who will be talking on this subject in the coming 3 days, starting with none other than Professor Gupta. So I'm not an expert on this, but I would look forward to hearing from the experts directly, starting with Professor Gupta. Before I request him to take over, a brief introduction of Dr. Anil Gupta. He's a resilience and sustainability strategist who has worked for the government, industry, and academia for over 25 years. Presently, he's a professor of India's National Institute of Disaster Management. He has steered several international and national projects of policy planning and research and published over 25 books and 70 papers. He is WMO expert team member on climate statement, South Asia Core Group member of IUCN-CEM, and vice chair of Association for Occupational and Environmental Health, and editor of Springer Nature book series on disaster resilience. With his immense experience on the subject, I think we all are looking forward to your presentation and to your lead lecture. Over to you, Professor Gupta.
Thank you, Ruwa, for inviting me and for introducing me to the participants. And since this training program is after my talk, it is going to be followed by the very specific topics to be covered by the subject experts. I chosen to give a little overview and also some glimpses on the importance and the mechanisms of risk assessment, because within the disaster management system, the entire story begins from recognizing the challenge. So that is the first step that how efficiently and how prudently we recognize, we identify, we recognize, and we analyze the risk and risk scenarios. So that sets the tone for the disaster management planning, and then management by implementing that plans. So thank you for allowing me to share my presentation. I am is my PowerPoint visible? Sanjeev?
Yes, sir, visible. Yes, sir, visible.
Yes, sir. Yes, sir. Yes, sir. We can see.
Yeah, thank you. So as Mr. Ruwa was also referring to that, how industrial safety and disaster risk management also contributes to the corporate, the prestige of the corporate houses or the industrial houses. So I would say that I look the industrial chemical disaster management or disaster management in general, including now the experience of COVID also, for industry as a business sustainability strategy. Because now in COVID, we had seen the kind of ups and downs, and not only ups and downs, but severe disruptions of many of the business and industrial entities. So disaster management is emerging as a very, very important dimension of the business continuity management as well as business sustainability strategy. And this is just a glimpse of the importance of chemical industrial disaster management, that we can see the missile man of the day after Dr. Kalam. He was the next to him, and releasing a resource book on chemical industrial disaster management. Now this is the framework showing the paradigm shift for quite a long time our focus has been on emergency response within disaster management. Yes, emergency response is still very important, because when incident takes place, so counter disaster measures are containing the incident to not allow it to cause severe damage or on health in terms of the morbidity and mortality. That is important, but what is important that we start looking at the disaster management as a management subject. And that is why this wheel, the first wheel, is bigger, because this requires a lot of planning process, lot of analytical exercises, and even discourses also, lot of discussions, and then regular improvement kind of things also. Then we recognize that despite of the best efforts of preventing and mitigating a disaster risk, there will always remain a some kind of a residual risk that also we relate with the concept of risk acceptance criteria. So we say that acceptable risk. So what risk that accept, and on the other term we call it the residual risk, that the remaining risk we need to prepare for dealing with that kind of emergency. So this is the new approach globally, where we are giving a little more emphasis on risk management, and then getting more prudently ready to manage our operations more effectively, so that we can reduce the losses and damage. Now, talking about industries, for quite a long time, when we were talking about the safety within industry, though, so fire and explosion, that has been the top consideration, because many of you must be aware that we start with Dow and Mond index kind of thing, that what kind of material, how much material, and what is the risk of fire and explosion. But a number of incidences that took place, including the Bhopal disaster. So how toxic release, the release of toxic gas or release of toxic liquid, or in other forms, so that can lead to a major challenge and take the form of an accident and then disaster. Then corrosion also, many times the corrosion of pipelines and these kind of things. Then we also added radioactivity. But beside this, we cannot ignore, when we are discussing about industrial safety and disaster management within the industrial premises, then mechanical mishaps and electrical accidents cannot be ruled out. On the other hand, we also listed a number of natural hazard factors that also contributes to the disruption within the industry, because now we are talking for disaster management as a measure for business continuity management and business sustainability management, and therefore we need to recognize these kind of natural hazard factors, and sometimes natural hazard factors and the man-made or the technological hazard factors are reacting with each other, are combining with each other, and creating a major catastrophic scenario. For example, what happened in Fukushima, that a technological a natural factor that earthquake led to tsunami. Then tsunami caused flooding, and then finally it affected the nuclear power plant, and it was a nuclear mishap. So how these kind of disasters, which in other terms sometimes we call it complex emergency, are NATEC disasters, natural induced technological disasters, are also equally important. Even in the China earthquake also, there were severe damage to underground chemical storages and chemical industries. Even Bhuj earthquake also has affected chemical industrial plants. In Orissa super cyclone also, a number of chemical storages have been affected, and even in the port area also there were the incidences of significant hazardous chemical spillage. So these kind of incidences were also there. Now we are also listing terrorism as potential threat, because sometimes the terrorist attack can also lead to major technological catastrophe or technological mishap, because by releasing hazardous or obnoxious materials. So but beside this, it is very important to refer to the trigger mechanism, because any major accident takes place once the hazardous material or the material that has a potential to catch fire or cause explosion, or if release is of the corrosive nature, or the toxic nature of the material. So that requires actually a trigger mechanism, and trigger event is very important when we carry out the process of risk assessment, whether it is a pre-incident risk assessment or post-incident accident analysis kind of thing, that what actually caused the trigger. So it may be a process or a storage system failure, or the instantaneous bulk release of the pollutants or contaminants. This is coming picture very recently, when sometimes even the failure of the ETP or STP can also cause sometimes the mass released from the natural sources. For example, from the pyrite rocks, there were incidences where some people died because of the release of hazardous gases from the natural areas also. Then spillage from the hazardous waste, then spillage are released from the transport or shipping. Natural calamities, I already discussed about terrorist attack also. Then there are also a number of incidences of mass poisoning, whether intentional or unintentional, that a large number of people have been served some food, but because of the poisoning, many of the people got ill, or they need to be hospitalized, or some people lost their lives. So these kind of incidences were important, and therefore they kind of the scope of discussion on chemical industrial disaster management has grown over the years, and now a number of factors have been included. For example, now we are also considering the impact of a chemical disaster, direct and indirect. So it can affect the human beings directly, or other animals and plants directly, but it can also affect the human beings and other life forms through the route of affecting our geological systems, including soil and water systems, natural resources, atmosphere, and so that route is also there, and it can also lead damage to property by way of if explosions are there. So it can cause damage to property, buildings, and machinery also. But it is very interesting that many of times we talk of emergency response as if that is the only important thing. But in fact, when we discuss about industrial chemical disaster risk management, then emergency preparedness is actually the last or the third layer of the defense mechanism. The first is that we avoid and we reduce the risk of any kind of a trigger mechanism. Then second is that if the trigger takes place, or if the incident is there, that we say that how we contain the incident. So how we contain the incident so that it does not convert into a significant accident. So that is the important dimension that has been added recently. This is also a kind of a lesson from experiences, not only in European countries, but India's experience has also been very significant, because India is the land where the worst industrial accident of human history has taken place, that is Bhopal. So there also we realize that even the land use is a very important aspect, and environmental settings that includes the eco-geophysiographical dimensions. So that is very important, whether we are using any kind of a runoff model, or the liquid discharge model, or the release of the obnoxious gases forming the vapor cloud, or causing explosion, or the vapor cloud explosion. These kind of scenarios that we use when we do our risk assessment, particularly the physical effect modeling. So land characteristics is always very important, and when we say land, it also takes care of the surface roughness parameters, including the buildings. So the concept of the kind of that the safety or the disaster risk management has to start from the industrial siting criteria itself. So that is the kind of important lesson. So start from site risk assessment, then hazard risk assessment, then looking into the multi-hazard assessment, because natural and man-made factors can interact with each other and can lead to the complex emergency. And that is why we have put in this terminology called maximum credible accident and accident scenarios and consequence assessment, because Physical effect is the first layer effect, but how the physical effect affects the vulnerable people, vulnerable land use, or the property and whatever machinery is there. And that actually determines the final consequence of an accident. So that final consequent assessment is also very important in order to prudently develop emergency plans, and then the entire cycle, entire all the stages of emergency management. So this is very important dimension that has in fact expanded the scope of disaster risk management. This is just a glimpse of the national discourse that we had with industry and academia, and a number of experts were there from all across the country for developing National Action Plan on Chemical Disaster Management jointly with Ministry of Environment and Forests. And here, if we see that what I was discussing about the land use, so identification of suitable sites for industrial locations or suitable sites for for waste disposal kind of thing, particularly hazardous waste. Now, even electronic waste is also, processing of electronic waste is also coming up, very, very important dimension. Then new human settlements. Why these kind of things are important? Because land is now becoming the most limiting factor. There was a time we used to talk that water is the most limiting factor, or air is going to be a serious issue. Yes, air is a serious issue, as we have been witnessing the air pollution episodes also. But I would say that at large, land is the real limiting factor, because all the developmental settings are going to be located on the land, and that is the real crisis. And this crisis leads to land use conflicts, and whenever industry is allowed to establish, we sometimes are not able to enforce two-way land use controls. Whereas I say that if the industry is allowed to establish, initially industry should not be allowed in the human habitat area. Yes, there are regulations and proper care is taken for the industrial siting. But many of the incidences we have seen, including the Jaipur fire and this recent Visakhapatnam incident also, that when the industry was given site, it was no population zone or no habitat zone. But gradually, a number of people start coming and getting settled down nearby the industry, and then those temporary colonies convert into the permanent housing and permanent infrastructure, and that actually leads to land use conflicts. So, how to address these things, that also need to be taken care, particularly when we are developing the disaster management plan for the government side also, because we need to look at that how we are going to address these issues. Then there are two important aspects of industrial chemical accident risk management. One is the process logical control and technological dimension, but on the other hand, the personal and behavioral dimensions. Because within the risk assessment process, we have two methods. One is the HAZAN, that is hazard analysis. There we use the Dow and Mond index kind of thing. So we analyze that how the material and the inventory based on these, what is the hazard potential, how what can be the physical effect scenario, but how the physical effect scenario will get a trigger. So how the failure incident will take place. There human mistakes or human behavioral dimensions play a great role. And that is why the HAZOP is very important exercise, that is hazard and operability analysis. So operability is basically how you operate. So whether you operate mechanically, how you operate through the logical systems, or through automation, but always there are human angle involved. So that is very important dimension we cannot ignore. Besides this, this is also an important lesson based on the analysis of number of accidents over past 2 or 3 decades. That many times we find that any major incident or major accident give some kind of a early warning. There were always some kind of a signal, some kind of alert signals, including Bhopal disaster also. Before Bhopal, a few months before Bhopal disaster, there was a death because of the exposure to phosgene gas, and in Kolkata bridge collapse, Kolkata flyover collapse also we see, or any other kind of industrial mishap also we see that there are small incidences, but sometimes we tend to ignore these. So the lesson is that if we do not ignore these, we will get effective signals that something is going to be wrong and something going in wrong direction. And that is why I say that the accident reporting system is very important aspect of industrial chemical disaster management. And here, in fact, misses and near misses are also equally important, and those should be analyzed with using the mechanism of the accident analysis or the forensic investigations of the incidences. So that gives a good insight to foolproof our industrial and process safety systems. Then this is a generic kind of understanding that how we understand disasters, and risk is basically an indicative of the probability. So it is not sure that that scenario is going to take place because it depends a number of other factors. But there is a difference between natural disaster and industrial chemical disaster, because industrial chemical disaster, most of the things are are under human control, and therefore the concept of zero tolerance can be applicable in the management of technical, industrial, and chemical disasters. So these are the kind of things. Then why risk assessment or risk analysis is important? Because any kind of a alert or forewarning or forecasting can help us manage the risk in a way that the unwanted situations can be avoided, and if cannot be avoided fully, the size of the incident can be reduced to the great extent, so that the incident can be contained without allowing it to cause the major damage. So that is important. Then also, if something happens, what can be the damage potential, what can be the consequence, and then take decisions to control systems. For example, whenever any kind of incident takes place, so what is the safe shutdown procedure? That is always very important, that safe shutdown procedure. And then evaluating the effectiveness of the control measures, so that we can also have the technical improvements. Then this is the general layout of the risk assessment emergency planning steps. We kind of we cut down the entire plant or entire industry into various maybe based on the plants or the location wise, so that because each and every segment of industry has its own different set of hazards and different set of vulnerabilities. The vulnerabilities can also vary, particularly the human exposure can also vary by the shift. For example, night shift, there will be lesser people as compared to the day shifts. So all those things have to be taken into consideration when we are moving towards a quantitative risk assessment. Quantitative risk assessment gives us a more characterization, detailed characterization of the risk, and they are actually we move to the probabilistic risk assessment by combining the what if analysis kind of thing, and then it leads to on-site and off-site emergency planning. So these are more detailed account, as I already discussed about the fault tree analysis and the event tree analysis. Fault tree analysis is the forensic investigation that if something has already happened, so how we go back. For example, what we do in our forensic investigation. Many of you might have seen that CID and other kind of investigative serials and movies. So when something has already taken place, we go back and try to find out the real culprit, or try to find out the real scenario, which are the trigger event that has been responsible, so that we can improve the situation for the future. But on the other hand, the event tree that builds upon that. If something happens, what will happen? Then if it happens, what will happen? So that kind of alternative routes are identified, and then we built upon and create the possible scenarios. This is about just a glimpse of the fault tree analysis, that if something happens, that there are two possibilities. Then if the release of chemical through relief valve takes place, then what are the possible scenarios? So it is like this. Then risk estimation. This is very important, because we talk of the acceptance criteria. So particularly in order to understand that what is the risk, whether it is under the acceptable criteria or not acceptable. Because the purpose is there is a terminology that is called ALAR, as low as reasonably practical. The ALAR principle applies here. Is risk acceptable? If it is not acceptable, then we have to work to bring it down to the acceptable level, because risk cannot be brought to zero. We always have to work with risk. We always have to live with risk, but risk has to be brought to acceptable zone. So that is the LR principle. And there are a number of models. Particularly now we are using a blended approach, because now we are trying to plot the risk and the hazard scenarios and the consequences on the geological maps or on the land use map, so that we can understand that if something, if the vapor cloud explosion takes place, which direction the impact will be there. If the explosion occurs, then to what extent the glass window can be broken, to what extent there will be heat waves, and then to what extent there will be shock waves. So, for example, then we also can understand that the people exposed to this, whether they will have a burn injury or they will have other kind of injuries or only other kind of shocks. So these are very important dimensions for risk assessment. And as I already referred, that a human factor is very, very important. And that is why we are giving emphasis on trainings also, because if we look at the analysis of the past disasters, it is rarely found that the mistakes of the particular people have been identified. Many times that the assessment and reports of the incidences end up finding the fault with the technical components. But anybody would agree with me that the failure of the technical the components will also be the responsibility of certain operators, or the managers, or the supervisors, or the suppliers. So in order to improve the risk management system, we also need to look at the human mistakes very, very correctly, so that we can address the capacity gaps or knowledge gaps, or if there are some kind of flaws in the manuals, or any kind of trainings or curricula, so that can be addressed. As many of the engineers who are attending here, they would agree with me that when you have done your BE or BTech 5 years or 4 years, you are never taught about the reliability risk analysis, or the safety assessment, or safety analysis, or industrial safety, chemical safety, process safety kind of thing. But when you join the industry, some of you are asked to look after the safety. So now we have been talking with the AICT also, and many of the IITs and NITs have also already included the reliability engineering and safety dimensions, disaster management in their curricula. And AICT has also already issued a model curriculum on disaster management. So that is very important, so that our engineers have the basic understanding and knowledge. Now this is about the various kind of risk assessment. So many times we think that risk assessment is only one type, but looking at the type of industry, there may be a number of risk assessment mechanisms or methods that can be employed. For example, in a power plant, even the ecological risk assessment may be required, or health risk assessment may also be required, particularly the pharma industry and fertilizer industry, where a lot of chemicals are there. So it depends. Then process industry, certainly safety risk assessment is there. Then environmental risk assessment, health risk assessment, public welfare risk assessment, like how a mishap impacts your corporate social responsibility initiative. So that can also be taken care of. Then ecological financial risk also, like many times a major disruption or major industrial disaster can also lead to the disruption in supply chain, and can also impact the market to a significant level, and even the impact can be long lasting. And then socio-cultural risk also, so that can also be possible. Then risk assessment is a kind of a decision making or decision support system that is important. So it also follows that the common research methodology regime, that identifying the problem and then carrying out the risk assessment like a job. And particularly this is about the pharmaceutical units kind of thing. So this was included looking to the incident that took place in Visakhapatnam, what is the dose or what is the exposure, and then how it causes the impairment, health impairment, or the kind of a lethal level. This is just a listing of a number of mathematical models that are available for physical effect modeling. Like Vejan, we have been using for that is the World Bank support model that we were using for physical effect modeling. Then there is a SimTox. Then FET model is there. Fire explosion toxicity index. Then so there are a number of models which are available. Vejan I already discussed. Effects model is they are basically based on the kind of a material, and based on the wind pattern and softness criteria, it gives us the scenario, possible alternative scenarios. Then the models like Cameo and Aloha. Cameo and Aloha are the model that use your kind of a web-enabled GIS support systems. So we can plot the risk on the map. So these kind of a number of mathematical models are available. In case of the air dispersion or the atmospheric scenario, the Gaussian is the one of the common principle that has been applied. So now technically we have a lot of opportunities, lot of scope is there for improving our uh, uh, risk assessment process in India. But there are certain limitations, and the limitation is that still we are using the British accident and failure data. When we have Make in India program and a highly diversified chemical industry in the country, it is high time that we start developing our own accident data and failure data in the country. And then the international models which are available need to be customized to the Indian requirements, their weather condition, Indian terrain conditions. These kind of things are also important. Then as adaptability to conditions. So this is also important. And we need to look at the inherent limitations of these models. So we need to also have the alternative approaches, that also can be a participatory approach, because many a times that the community knowledge or community based information or the participatory information can also help improve the risk assessment process. This is about improving the emergency response and the resilience within industrial settings or industrial estates and industrial parks. That how various subset facilities or various infrastructure systems are depending on each other, and that sometimes causes major failure. So that may cause a kind of a chain reaction. For example, the electricity can determine the sustainability or failure of the hospital system, or the heating requirement or cooling requirement or the transport system. So these kind of things are also important. Now this is a new dimension, but very important and globally accepted, that now risk management need not to be looked in isolation from resilience and sustainability, because risk management is about managing a particular incident. So it says that known knowns, and also to extend that known unknowns, because we know the kind of scenario, but possibility or the probability we do not know when it will occur. So this is one thing about known knowns and known unknowns. But now we are required to move ahead, that how we make flexibility our systems. We develop redundancy also, flexibility also, so that our operation systems and management systems adjust to the changing scenarios. So that is important. Particularly, this kind of experience has emerged like the coronavirus pandemic period also, when we ask that the industry will operate with 50% of the staff or 30% of the staff. So how you adjust with your management mechanisms, how you adjust with your technical manuals or technical operations. So with the changing scenario, so that is also important. And then how the business continuity management will integrate the issues related with environmental emergencies, like Rua was also referring to black swan event, and like the coronavirus incident is considered as a black swan event, because black swan event is something which is a high intensity impact, but the frequency is least or very less. In the other words, we call it a kind of a maximum critical accident, where the probability is least but is still believed to be probable, and if something happens, it is of catastrophic nature. And then we need not to look at the industrial chemical safety or disaster management only for the present generation. So because any major industry or any major corporate sector or any major developmental setting is not only for 10 years, 15 years, or 30 years time. So new set of managers come and replace the old ones. New set of engineers will come and will replace the old ones, like what happens over generations. So similarly, the intra-generational safety issues, how we are going to address the facilitation of the safety and safety management by the future generation of the engineers, future generation of the industry managers. So when we integrate this risk management, resilience, and sustainability, then it provides it kind of a overall picture of a disaster resilience and disaster risk management within industry. Now I'm advocating very loudly, and I'm allowed to say this that all the industries, and particularly at the business house level, or all the industry unit level. So I say that the business disaster management is a new kind of a terminology that we have evolved, that all businesses need to prepare disaster management plan. They foresee that what can happen, so what can go wrong, what can happen if something happens, that what will be the consequence, what will be the scenario, and how you need to put your risk preparedness in place, and how you can coordinate for reducing the risk, reducing the impact of that kind of a unforeseen or unexpected incident. So that is very important. Then I already discussed that the business continuity regime need to integrate environmental emergencies. For example, recently we faced the severe level of air pollution. So how this health emergency or these kind of things are also emerging as a new challenge, and how businesses are going to integrate that. Then water emergencies, for example, the sudden contamination of water bodies. So how we are going to address these kind of things, then conflicts, then other natural factors, oil spill, e-waste, hazardous waste, these kind of things are emerging as a kind of a new dimension. The ultimate objective or ultimate kind of a one-liner from a senior top management point of view, for looking at safety and industry in safety and disaster management within industry, that I do not want any surprises. It means that you try to understand, and you try to identify, you try to analyze all possible scenarios, and then we can identify the MCAs, and then most important scenarios, and so that we are prepared more efficiently. So that is very important. And these are some of the publications from an IDM side on various dimensions of industrial and chemical disaster management, like how environmental legislations plays role, how GIS can play a role on managing industrial chemical disaster management. These can be freely downloaded from the website of an IDM, and I have also shared in the chat box my ResearchGate address. All my publications can be downloaded from my ResearchGate address, and freely in the PDF form. So with this, it is very important that we give impetus to the capacity building initiatives in disaster management within industry, and that should be not only a particular or the limited number of people or limited number of employees, but all the sections. So we can say that the top management, middle management, and lower and shop floor workers, all, and even the contract workers. So that is also important, that they are giving adequate safety training. And that safety, when I say safety training or safety, people say safety first. Many of the times we say that safety should be our priority. I say that mind safety. So mind safety, basically, it should be our thinking, that the top of our thinking, that whenever we think of any kind of a endeavor, any kind of intervention, we should think of safety. Whether we are traveling anywhere, whether we are constructing anywhere, we are erecting something, whether we are installing a new machine. If we recall the oxygen plant explosion in Vishakhapatnam in 2013, then some of you who must be knowing that kind of incident. So how the curiosity, or how the over enthusiasm can also lead to these kind of things. So both technical as well as human management, both comprise the important dimensions of chemical industrial disaster risk management regime. So with this introductory talk, I hope that this training program is going to be very important contributions in this direction. Thank you very much, and over to you, Mr. Ruwab and Mr. Sanjeev. Yeah, Ruwab.
Thank you so much, Professor Anil Gupta ji. Thank you for your very detailed lecture. And there is a reason I would like to share with all the participants, who are over 400 in number now. There's a reason we have this lead lecture, and this can be made by none other than Professor Gupta, who spent decades together, professional career in developing such important national not only guidelines but also framework, and he's advising and been a key source of knowledge for many industries and industrial bodies and regulators in the country. And we really thank you,
Thank you.
Dr. Gupta, for your very enlightening presentation. I think it sets, in the right sense of the word, it sets the perspective to the coming 3 days of what the participants should expect and must expect that they would learn. I'm sure it has triggered a lot of interesting discussions and arguments in the minds of the participants and the listeners. And I encourage them, if they have any question which they would like to ask Professor Gupta, or to Shri Madan Mohanji, who is our next speaker, please feel free to ask those questions, type those questions in the question and answer window. After the presentation of Mr. Mohan, we would take those questions up, and we'll facilitate answers from the experts directly. I think for Professor Gupta, very, in his detailed presentation, touched upon very critical aspects, which may sound very, in a form of commonsensical to a lot of people, but sometimes why this has been reinforced and re-emphasized is because they are ignored at times, which can lead to, catastrophes, of proportions, which in a country like India do not need any reminder, because the largest and the biggest industrial disaster, as Professor Gupta mentioned, was the Bhopal gas tragedy. And I think it is expected out of us that we take this subject all the more seriously, because the largest accident happened in a country like ours. And we are fast growing into becoming one of the most industrialized countries in the world. In fact, the Industrial 4.0, when we talk about that, Germany is taking a lead in that, but India has been taken more seriously than ever before in formulating the entire scope of work, and in detailing the industrialization industry 4.0 guidelines and framework. And I think it is, as I said, it could not have been a better moment for us to talk on this subject, because uh, from a commercial point of view, nobody would want to do, and I'm sure Professor Gupta and Mr. Mohan will agree with me, that nobody wants to do business with corporations that risk the quality of the product and the safety of their employees. It goes hand in hand. To increase the bottom line, if somebody would compromise with the safety of their employees, it will have maybe bigger impact than the quality of the product would have on the business of a corporation. Companies who care about their employees put them first, and when that happens, productivity increases. That's the formula. Suddenly, the employees is no longer just a number, but a person who can actually make a difference. And that is a culture which we want to, we are willing to promote, and that is the reason, Professor Gupta, I think the fan club, your fan club, is developing in thousands now. In last 7-8 months, I'm sure, with whatever push or whatever outreach we could ensure as CIDM at FICCI, with great support of the backbone, I call them, the Akhil Gupta, Sanjeev, Menak Majumdar, Varun Sharma, and your Harshit and Anjali from NIDM. I think we've been able to create a ek dhacha ban gaya hai, sir. This is something, and the expectations are high. So you can imagine, in 4 OTPs, 400 से ऊपर हमेशा delegates आए हैं. This is really overwhelming, because with 4th or 5th we would have thought the numbers will come down, but every OTP we are in between around the 500 to 400 to 500 mark. And I think this is a great, I know the quality is superb, the content, this is a testimony that the content which is being brought together or being compiled is great quality. But as you always say, Professor Gupta, that the biggest compliments and appreciation for the team, which has made sure that these participants have a platform which is seamless, which is technically sound, where they can gain the most. So thank you again, Professor Gupta, for your very enlightening speech. Thank you so much. Ladies and gentlemen, now moving on to the next speaker. And he's a great professional, a very known personality in the oil and gas business, and also when it comes to industrial safety, then almost across all sectors. Mr. Madan Mohan, is a known personality. He's the DGM of project execution at GAIL India. A brief introduction of Sri Madan Mohan. He's a graduate in mechanical engineering from HBTI Kanpur and MBA in marketing from Agra University. He has experience of 18 long years in O&M of natural gas pipelines and compressor stations, project execution of cross-country natural gas pipelines. He holds NACE CIP Level 1 certificate, ILI Masterclass certificate by ASME, Certified Energy Auditor from BEE. He is IPMA Level C Certified Project Management Professional as well. Presently, he is working with Corporate Project Execution Group at Noida, at GAIL, involved in project execution of cross-country natural gas pipelines. So, on that note, Mr. Madan Mohan, over to you. And for all the participants, for your interest, I'm sure a lot of us are aware that natural gas pipeline is perhaps in India is perhaps one of the fastest growing sector across any industrial sector, if you may say. This is the fastest growing network, and it has been something which is closely been watched by the global giants also, who have in developed and developing countries, that the work which we are doing in India, and GAIL is the leader of this entire network. I think my congratulations and compliments to GAIL and to Madan Mohanji to use as well for the great work which has been executed under the flagship, the Navratna company, GAIL. We are really proud of the work you're doing, and we look forward to your presentation on safety through pipelines, pipeline integrity management. Over to you.
Thank you, Mr. Vasu. Thank you for this wonderful introduction. And I would like to thank you, Dr. Anil Kumar Gupta, Head NIDM, General Bharadwaj, team from FICCI comprising of Mr. Akhil, Mr. Sanjeev, Mr. Mainak Majumdar, and dear participants. A very good afternoon to you all, and I'm grateful to you all for giving me this opportunity to put forward my views on safety management of natural gas, cross-country natural gas pipelines. I hope my voice is audible. Yeah. Just first of all, I would like to take you through GAIL's portfolio in our country. As Mr. Rubab already mentioned, we are the largest pipeline operators in country. We are operating around 12,000 kilometers of natural gas pipelines and with around 2,000 kilometers of LPG pipelines running across the length and breadth of the country. Also, we are having around 1.4 million metric tons per annum capacity of liquid hydrocarbon production, that is LPG, naphtha, propane, pentane, and other value-added products. They are derived from natural gas only. We are also having participation in exploration and production blocks in India as well as in offshore countries also. And we are committed to promoting clean and green energy through operation of several city gas distribution networks, CNG stations, which are through our joint venture companies and wholly owned subsidiary GAIL Gas Limited. We are also having participation in this RGPPL Ratnagiri Power Plant, which is a power plant based on natural liquefied natural gas. Further, if we look at the pipeline scenario in India, you can see we are currently at around 17,000 kilometers of natural gas pipeline, in which GAIL share is maximum around at 12,000 kilometers. Presently, we are operating, and in next 3 to 4 years, we are already going to add around 7,000 kilometers of pipeline to our network. Combined with this, other operators also will be having a capacity of around 33,000 kilometers of pipeline, natural gas pipeline in our country in next 3 to 4 years. Similarly, this crude oil and other petroleum product pipeline, we are around at around 28,000 kilometers. So this is a huge network which is spread across length and breadth of our country, as you can see in this map. So this itself poses a lot of challenge. How can we be safe while we operate the pipelines, we transport the gas, or we transport the petroleum products? They are highly, for safety point of view, they are highly dangerous. But we follow the safe procedure practices, we can mitigate the risk. As Dr. Gupta earlier pointed out, the first line of defense. The first line of defense is the management of safety, the management of integrity. Why this integrity management is important as we talk about pipeline or any other assets? There are few very basic things like management of threats and prevention of failures, safety of the people and surroundings, environment. We have to comply with the regulations. We have to optimize the expenditure as well as optimize the risk to the business due to any mishappening or catastrophic event. If we look at the data that is gathered over the period of time, we can see the maximum number of accident or incident in pipeline happens because of third party damages or encroachment. Coupled with that, there are several factors like internal corrosion or external corrosion or natural causes or not following proper operation and maintenance procedures. But this encroachment remains number one, as already pointed out by Dr. Gupta, that when we lay a pipeline or we install or commission a plant, it is away from population area. But over the period of time, the population around the plant or pipeline, it increases and it changes the land use. So there are several land use conflicts, and that's a major challenge for any pipeline operator or any process plant operating in the country or worldwide. So how do we overcome the challenges to natural gas pipeline safety or integrity? We have to have a systematic approach towards management of integrity. This integrity management program provides means to strengthen the safety of the system. Any integrity management plan, a very good integrity management plan definitely has elements like management plan, the performance metrics, the communication plan, management of change, and quality control. These are all as per ASME B31.8S. If you look at the flow chart, the first step is first of all we have to gather as many data as possible. Then we analyze them, we review them, and we assess the risk, that is critical risk assessment. Then based on that risk assessment, we assess the integrity of our system or a pipeline. Based on that assessment, outcome of that assessment, we prepare our response and mitigation measures. Then again, it is put to performance metrics to determine its effectiveness and for future corrective actions. Now, there are several threats to pipeline integrity. The very first step is to identify what are those risks. What are those conditions which can increase the risk to my pipeline or any asset? Any root cause, it is labeled as threat to the pipeline or asset integrity. And as pipeliners, we identify the threats or risks on segment basis. Although we are operating the pipelines in the entire length and breadth of the country, we cannot go at one stage for all the pipeline network. We do it segment wise. For analysis of risk, we rely on well-known practices like knowledge-based or experience-based risk assessment, scenario-based risk assessment, relative risk models, probabilistic models. Like you all be aware about risk probability metrics, that is probability and occurrences, probability of occurrences and consequences of those occurrences. We get a mathematical number and we put across a table like this. The darker the color, the more risk is there. For any pipeline, we can classify the threats like time dependent, which are there as we operate the pipelines dependent on times. Then we can categorize them as stable threats. The threats that are already known when we are constructing a pipeline or installing an asset. We already know what can go wrong, like in pipeline welding or during coating process, during installation of any equipment. What type of things can go wrong? We already identify them and we try to minimize those defects. Then there are defects due to third-party encroachments, damages, or incorrect operations, or other natural causes like lightning or floods or earthquakes. There are these are few examples of time-dependent threats like corrosion. Corrosion is number one enemy of any pipeline asset, be it internal corrosion or external corrosion or corrosion due to stress existing in the pipeline material. There are stable threats like welding defects or manufacturing defects in the pipeline material. Then there are time independent threats like this can happen any point of time if you are not proper about supervision or surveillance of our assets. That can be done through mechanical damage by third party or any other natural causes. As per ASME B31.8S, it guides us about what methods we can use for integrity management of our pipelines. Based on the priorities which we determine through risk assessment, we have several methods like inline inspection. That is, we insert a intelligent tool in the pipeline which flows along with the fluid, and it inspects and captures the relevant data for us for further analysis and establishing the health condition of the pipeline. Then there is another method of pressure testing, then direct assessment where any inline inspection or other technique is not used, then we use direct assessment. We'll talk about it later. See this pipeline integrity management process. It's a continuous process. It starts with during the concept and commissioning stage. Then it is transferred to the operation stage. Then it is continued till the pipeline or asset is in operation, and it ends with abandonment of that asset. So during the life cycle of the any pipeline or any asset, we have to have inspection monitoring mechanism, integrity assessment methods and techniques. Then based on that assessment techniques, we have to have a mitigation and repair plans. During design and construction, that is to avoid the stable or known threats, there are several techniques, as well as there are several techniques during the operation and maintenance phase. Like during the design and construction of any pipeline, we can have sound design principles. We are constructing our pipeline as per the international standard, that is ASME or ANSI standards we are using. We are using latest technologies, be it related to uh, pipeline material or welding techniques or coating techniques or inspection methodologies. We are suitable this selection of material for pipeline. We are using carbon steel mostly, but depending on the situation, if we have to lay our pipeline for corrosive substance use, we can go for additives, and we can have superior metal properties like alloy steels. We can have polyethylene coating. We can have reliable cathodic protection system, that is to safeguard the pipeline against the damages from external corrosion as well as to some extent from internal corrosion. We can have the selection of pipeline wall thickness as per the population density. That is again driven through international guidance document like ASME B31.8. These corrosion resistance alloys normally we use during transportation of very toxic fluids through the pipeline. Normally in natural gas we do not encounter such type of problems, but at times like in crude oil pipelines we have this kind of problem where we have to rely on this corrosion resistance alloy. Additional precautions like we can have corrosion allowance inbuilt in the pipeline thickness. Whatever is required as per the formula PD by 2T, we add certain say 1 mm or 2 mm to that thickness as corrosion allowance. Minimum ground cover of 1 meter is provided as per guidelines. All the welding joints, they are 100% inspected through radiography methods. We carry out hydro testing of pipelines before we commission them, before we put in the gas in the system. That is, whatever is the design pressure, we take 1.5 times to that design pressure, we hydro test the pipeline, then we use it. All the pipelines are 100% internally inspected before they are put into the service, so that we can have a baselining data that this is the condition of my pipeline before we started the operation. And over a period of time, going through various techniques, we can compare or assess the internal conditions of the pipeline. During the O&M phase, we have several assessment tools for integrity, like in-line inspection. We have several type of tools like caliper pegging tool, which captures the geometry of the pipeline, whether it is having some mechanical damage which is not visible to us since it is underground. We have corrosion detection tool, which can detect and size the corrosion, extent of corrosion and its location. Based on that, we can plan our mitigative action. Axial fraud detection tool, XYZ mapping tools, they are all somewhat similar type of tools. Then we have cathodic protection monitoring, where there are several components to this system, like cathodic protection power supply module or transformer rectifier units. We closely monitor them, we take their readings and we analyze them, and we put into our prior experience. Based on that, we infer what is the condition of pipeline. Then on off PSP surveys, like pipeline is going through remote areas, deserted areas, as well as populated areas, but we carry out this PSP survey just to assess whether my coating condition or health of the pipeline is safe or not. Then several other methods like anode bed resistance monitoring, CPL DCVG, direct current voltage gradient, like this is used for assessing the condition of coating. This pipeline coating, that is 3-layer pipeline, 3-layer polyethylene coating. This is the first line of defense of any pipeline for protection against corrosion, be it external or internal. This direct current voltage gradient, it shows us whether there is any defect existing in the coating. If at any place, if coating is peeled off due to any reason, mechanical or man-made, we can get to know without digging the pipeline. We can get to know where the problem might be, and there we can go and intervene. Then surveillance, like patrolling on foot patrolling or through air surveillance or through electronic media, like we are installing CCTV cameras across all our SV stations or IP stations or compressor stations, just to know whether all the things are under control and no surprises are encountered in day-to-day operations. Hydro testing we already talked about. Then direct assessment and evaluation, like external corrosion direct assessment and internal corrosion direct assessment. These are assessment techniques which normally, where we do not employ the earlier testing method like inline inspection, where we cannot insert a tool into the pipeline. We rely on this ECDA or ICDA, or direct assessment, we can say. Then thickness assessment is a proven technique where for all the installation where pipeline is coming above ground, we monitor the thickness through ultrasonic probes and we compare it with historical data to know the condition of our assets. There are a few examples of surveillance using helicopter or foot patrolling. The importance of surveillance is to know whether my pipeline having some vulnerable high consequence area or vulnerable location, like near the river banks, near the road crossings, or near the nalas or canals, or where any type of landslides or flooding can happen. We carry out uh, once in 2 months the survey through helicopters, and annually we carry out the patrolling through walking on foot over the entire length of the pipeline. There are several standards like OISD and PNGRB guidelines, which specify what type of frequency we should adopt while we are patrolling the pipeline on foot. In class location 3 and 4, which are mostly urbanized areas, if we have any pipeline near these class locations, we carry out daily patrolling Although the guideline says we have to carry out the patrolling only once in a month, we are carrying it out on a daily basis through our contact manpower. These are some pictures taken while carrying out food patrolling or survey of ROU. Then there are cases like we have to cross already existing pipeline, and there has to be abundant precaution taken while we are laying a pipeline or doing any maintenance like bonding of CP. This is very important so that there is least interference because of other pipelines cathodic protection system. Then another important aspect is gas quality monitoring. This natural gas pipeline, see, we are very careful about what we are putting into our pipeline. We have to transport it thousands of kilometers from one place to another place. We simply cannot afford to bypass this quality aspect. If you are allowing any type of impurities like H2S gases or CO2 gases or moisture into the pipeline, they can cause chemical reaction and they can lead to production of acids which are detrimental to the steel of the pipeline. So we are installing gas dryers or gas sweating units for uh, reading the gas of moisture or toxic gases like H2S and CO2 basically. We have several gas analyzers like H2S analyzer or moisture analyzer or gas chromatograph where we can get to know what is the composition of gas we are going to put in our pipeline, so that based on the readings and based on the standards we can stop it or take the preventive measures. Sometimes we have to, despite all these precautions, we have to have chemical treatment just to avoid any ill consequences of the product which is not conforming to our quality requirement. It is entering in the pipeline. We have to manage because huge volume of gas flowing through the gas pipeline, and any impurity, whether it is in ppms, that can accumulate over a time and cause trouble for us. So we have to rely on chemical treatments like we inhibit corrosion inhibitors in the pipeline, we inject corrosion inhibitors, we inject biocides which avoids the formation of bacteria. Yeah, that's a funny concept, but we do encounter some type of biocides induced corrosion, internal corrosion in the pipelines. We control the hydrate formation with the help of methanol. This chemical treatment depends on several factors like what is the rate of corrosion in our pipeline, what is the severity, and what is exactly the root cause of the problem, what type of element which is entering our gas pipelines which is causing problem. This corrosion inhibitor application, it has to follow a proper set procedure. We have to rely on third parties testing to verify what type of dosing we are doing. We have to have a proper documentation of what quantity and at what time it was injected. Then biocide selection, it has to follow a protocol as defined by NACE, that is an international body on corrosion control. These are apparatus for injecting corrosion inhibitors. In corrosion monitoring of pipeline, we have to attack it in two directions. One is prevention from external corrosion, that is taken care through proper coating of the pipeline as well as having cathodic protection. And second is internal corrosion. For cathodic protection, there are several elements in that like CP, PSM monitoring, PSP monitoring, all these frequencies, how and what frequency we have to monitor them, that is defined by international standard as well as our very own standard recommended by OSD and PNGRB. Sorry. Then we carry out cathodic protection surveys, which includes on-off PSV surveys or closed interval potential logging. We carry out the on-off PSP survey and we plot it using a software, and we get to know some inference about the health of the pipeline. direct current voltage gradient, it again talks about how is the condition of my coating over the pipeline. Then based on these assessment, we carry out the mitigation action, whether it is uh, rectification in the coating or checking whether pipeline is touching any foreign object or removing that thing from the pipeline which is causing trouble. Then another method for coating integrity is peel off test. Over a time, due to improper cathodic protection current or some chemical reactions due to the material which is used for fixing the coating over the pipeline, it can have some reaction and cause the coating to peel off. It desponded with the pipeline. So to determine the extent of despondment, we carry out peel off test, which is following a already elaborate procedure. We carry out by having a 25 mm silting across the coating, and we peel it off using certain force, and based on the readings we compare it with the coating condition, and we get to know whether it is suitable for future use or you have to uh, intervene and repair it. This internal corrosion monitoring, like already talked, like corrosive constituents like H2S and CO2 coupled with moisture, they can cause trouble for any pipeline operator in long run. So we have to follow a lay down procedure. We have to install corrosion coupon for monitoring and analysis. They can be of several types like electric resistance probe or electrochemical noise probes. We have to install them at certain locations which are based on certain modeling where we have to use it for analysis of internal corrosion. There are several other considerations also in mitigation and monitoring of this corrosion, like critical angle at which we are entering the gas into the system, what path it follows during its journey from one place to another place, what is the volumetric discharge rate of the fluid which is transported in the pipeline, operating pressure and temperature, biological assays, what type of biocides we have to use, or what is the water dew point, or what is the topography of the pipeline alignment. We have to consider these aspects also while designing a corrosion monitoring system. There, these corrosion monitoring system, like we talked about electrochemical noise or LPR probe or ER probe, they can be classified as direct or indirect. Indirect means we get certain readings and we infer what is the level of or extent of corrosion happening in the pipeline. Then selection of the monitoring location. It is very important where we put in the probes for monitoring of external or internal corrosion. Area where corrosion is more severe, it can be predicted through internal corrosion predictive modeling. That's a software-based approach. Or inline inspection, we get the data from inline inspection where the problem is likely to happen or where the problem is already existing. These are some photographs of the electrical resistance probe and linear polarization resistance probe. These ECN probes. This another very useful technique is electrical field mapping probe, which is normally it captures internal corrosion to the range of 0.1% of the wall pipeline. You can see the pipeline average thickness is around 6.4 mm. So 0.1% of that thickness it can capture whether corrosion is happening at that rate or not. Another useful method for assessing the integrity is pigging of pipelines. Pigging of pipeline starts with cleaning pigging. Cleaning pigging is very versatile tool. It not only used to clean the pipelines, it also gets us all type of impurities removed from pipeline, like these corrosion products or some sort of condensates or other impurities which may exist at the time of commissioning. There are several types of cleaning pigs depending on the uses, we classify them as foam pig. Foam pig is very basic pig. It is made up of a foam, and it is used to assess the piggability of pipeline, whether my pipeline condition allows me to run a tool across the pipeline or not. If there is any problem, this foam pig can be disintegrated due to the force of flood flowing in the pipeline, and our operations are not hampered. Then another is gauge pigging. It checks out the roundness of the pipeline. Another is brush pig to clean and scrap the pipeline, and magnetic pig to collect the ferrous debris, which which are normally formed due to corrosion happening in the pipeline. At any point of time, you cannot totally avoid the corrosion phenomena happening from the ferrous products, whether it is pipeline or any other structure. These are some pics of the foam pigs. Then these intelligent pigs, they are very effective means of capturing data of the pipeline by running a tool through the internals. These are high resolution magnetic flux leakage tools. Means we have a tool designed in such a way that a high resolution magnetic flux is captured, and with the very principle of magnetism, if there is any defect in the pipeline, that flux which is captured at other end, it distorts, and its signature is used to tell us whether the pipeline is having any defect or what type of size of that defect. It can be determined through this tool. There can be several types of intelligent pigs depending on the end use we are putting in, whether it is corrosion detection pig or axial flaw detection pig or XYZ mapping tool. XYZ mapping tool is giving us virtual image of the pipeline coordinates of the defect. Like by sitting at my computer, if we analyze this data from received from the XYZ mapping tool, I can create a 3D image of the pipeline, and I can very well visualize what type of defect and at what location it is occurring. Based on that, we can plan out our mitigation action. And there are different type of capabilities owned by each of these intelligent pigs. Based on the readings we obtain from intelligent pigs or any other integrity method, we carry out the mitigation plan. Like if we find there is any mechanical damage or there is any internal corrosion issues, we can go for leak repair clamps or pipeline coating, pipeline wraps we can use, or we can replace the pipeline altogether. Then another method is direct assessment. It comprises of pre-assessment like data collection and assessment, selection of direct assessment tools, and indirect inspection means without digging the pipeline and exposing it for visual inspection, we go for software modeling like ECDA or ICDA or terrain modeling for likelihood of stress corrosion cracking or future threat identification of potential area like where it is prone to earthquakes or landslides. We can know through direct inspection, indirect inspection. Then direct examination employs various entity techniques like this ultrasonic measurement or uh, sound measurement. We can employ these techniques. There are several new kind of technologies being employed by pipeline operators across the world. We'll talk about it later. Then after this assessment, we carry out the reassessment interval or remaining life assessment or effectiveness of the technique we use, and based on that we can plan for the future intervention. This is long range UT measurement or carrying out the thickness survey of the pipeline over a short length of pipeline. Like we talked about newer technologies being available. One of that is polymer lining, where in these pipelines where we encounter severe internal corrosion, we used to line it with this polymer. Polymer is nothing, just we put a sleeve but inside the pipeline by employing some mechanical forces. However, this technique is not widely used because it is very difficult for cross-country pipelines to have such kind of arrangement. It can be useful over a very short length of pipeline, say in the jetty areas or in crude oil pipelines. It can be used. We have this emergency response vehicle for attending to any emergency in the pipeline. This is basically a fire tender model with several amenities which can like gas detection or site barricading or site lighting or checking the pipeline location or depth of cover and lifting, pulling, leak repair clamps. All these can be put together in this emergency response vehicle, and it's a very handy tool for any pipeliner. Then another useful technique is optical fiber cable based pipeline intrusion detection system. See, this optical fiber cables we are laying along the main pipeline. It is basically used for our supervisory control and data acquisition system, which is a control system for any pipeline. Coupled with this, we carry out all our communication on this OFC carrier, as well as we call it a relay effect. The effect is that in OFC, if it detects any vibration, it causes a deflection in the optical image, which is captured at the other end, and it is used to interpret whether any encroachment or third party activities is going on near the pipeline or near this optical fiber cable where it is being laid. So we can have an inference and a sort of pre-warning that some party is going to excavate near your pipeline, or you have to go there and assess what type of dangers or what type of precautions you have to take care. Another useful intervention is remote methane leak detector. See, any natural gas, it cannot be seen with the naked eye, and most of the time it is odorless also. So either we install gas detector at each and every location. That will be a costly and time consuming affair. Another method is we are having these handheld monitors which can uh, which can assess the level of methane leaks to the tune of ppms. It can give us a forewarning that any equipment is leaking gas or it is causing fugitive emission of the product, and we can take timely intervention. This another method is this magnetic tomography method. This method is again, it's a variation of magnetic flux leakage principle. This is using Villari's effect. Villari's effect is like if you put any metallic object to mechanical stress, it will change the characteristics of its magnetic properties. So by measuring the change in magnetic properties, we can assess what is the condition of pipeline, whether it is undergoing certain thickness reduction, which is causing stress changes in the pipeline. Like that, we can infer. Another is CMDM, contact-less magnetometric diagnostic method. It is similar to the principle of MDM. It again uses equipment which relies on the principle of magnetic flux leakage and capturing to analyze the condition. Another useful tool is GIS-based pipeline integrity management system. This GIS-based or locational-based pipeline integrity management tool is very useful tool. We use softwares wherein we put all type of data which for analysis, whether it is received from ILI or direct assessment or certain other tools. We use them to plan our mitigation action, to know the condition of the pipelines. We identify the threats and what is the probability of those threats converting to potential catastrophic event. We score them, and we maintain a sort of history with this type of data for every pipeline segments. This computerized, yeah, centralized pipeline integrity management system, we can define it like during construction and operation phase, we establish and maintain the integrity. And during the life cycle of the pipeline, if any threat is encountered, we employ proper mitigation. And this keeps a balance for maintaining the integrity of the pipeline at normal levels. There are several statutory and regulatory requirements for maintaining the pipeline integrity management system for all pipeliners. It is driven through OISD 226 or PNGRB IMS regulations or ASME B31.8S. As a pipeliner, we follow these documents, we follow these guidelines and maintain our pipeline assets. With this, I would like to conclude my talk and thank you very much for patient hearing.
Thank you so much, Mr. Madan Mohan. As expected, I think it was a very well compiled and curated presentation. And while you were making the presentation, we were getting some very positive feedback from all the participants who were carefully listening to the insights you were giving about the oil and gas industry and the safety measures which are undertaken. At GAIL. And when we say GAIL follows or follows a path of certain operations or certain do's and don'ts, then it's safe to say that that is the best practice of the industry, and I'm sure not only in India, but that would be a global best practice. What GAIL would undertake in its operations, considering that it is one of the largest oil and gas companies in the world, and the flag bearer of India's oil and gas industry. So thank you so much. Again, one of the key aspects which you also touched upon, I think the hazards which are related to oil and gas industry are in two broad categories. One is of course, the safety and injury related hazards, and
Yes.
other is the health and illness related hazards. And I think all of that, because in an oil and gas sort of setup, with dealing with hydrocarbons and compressed gas and all of that, it need not be an accident of where a blast takes place, but even a leakage can be very catastrophic. And I think
Yes, sir.
you've touched upon very key aspects and the processes which are followed and been taken up in your industry. And I think that I really compliment you for that. And you also touched upon the ERDMP, which I think is the fundamental, I would say, book or the rule book
Yes.
for disaster management planning in oil and gas industry. And I think had joined FICCI back then, but the General Bhardwaj, who earlier spoke in his inaugural address, who was then the chair, the member of National Disaster Management Authority, he and Mr. Labendu Mansingh, who was the founding chairperson of Petroleum and Natural Gas Regulatory Board,
Yes.
and they came together along with their experts and their members in the board and other experts from the national authority to compile and develop this ERDMP document, the first ever document. And that is something we at FICCI CIDM board take pride in saying that, since that document was made public, through our platform, we've been propagating those guidelines amongst the oil and gas industries. And I think from all the oil industries, all the major Navratnas and Maharatnas of Indian oil industry and gas industry have been very supportive and logically so to our platform, to our initiative. And time and again, they've come on board of CIDM conferences and workshops to talk, not only ERDMP, which was developed then, but since then, whatever updations have happened in that document have been duly recognized and appreciated and disseminated on our CIDM platform. And this OTP is also comes from the same tree. It's another branch from the same tree, which is the Chemical and Industrial Disaster Management tree, which has came into existence almost now over a decade ago. So thank you so much for all your
Thank you.
comments, and we really appreciate the detail in which you explained all the points which are relevant to all our participants. Who, in fact, a few of them also mentioned that how could they, even listening to your interesting presentation, how could they actually um, you know, try and, I'm sure there must be young professionals, how they could develop a career in petroleum sector. And I think that's
Yes.
something very encouraging. And on our platform, uh, that's what we strongly believe in, that the participants, not taking away from other such initiatives, anything away from those initiatives, but what we do and the sort of participants we have on our platform are very relevant, and they mean business. They are really here to learn, and that is where we are also challenged as organizers to get them the best from the industry, the best of knowledge and best of best practices from which they can learn, and learn as industry professionals also, and also from the academia, who are looking for a career, who want to make a career, uh, can also find the right knowledge in our online training programs. So thanks again. And I also welcome Dr. Ashish Mittal. He is another health and safety professional who would be giving his presentation in coming days. Thank you so much for joining us, Dr. Mittal. You have been very supportive, and we appreciate your support and your guidance in making this program successful. Thank you. Uh, I have list of questions now with me. One of the things which I wanted to also share with all the participants, that once again, that you have to attend all the 3 days of this OTP to be eligible for a certificate, which will be jointly issued by National Institute of Disaster Management, Ministry of Home Affairs, and Federation of Indian Chambers of Commerce and Industry, that is FICCI. So you have to attend all 3 days. I'm sure if you attend all 3 days, you will end up into being a more, you'll acquire, more knowledge and be more learned by the end of these 3 days. The link for all the 3 days will remain the same as long as you use the same email ID. So for us, we will be tapping, WebEx has a facility of tapping all the attendance of all the participants along with the number of minutes and hours they spend on the platform. So we can track all of that. So there is no need for an attendance link, but use the same email ID to register, so that we know the same email ID has registered all 3 days. So do not use other email IDs. Use the same one. It makes it easier for us to track the attendance. So that was an important bit of information. Our videos are being also linked to the YouTube channel, FICCI's YouTube channel. In fact, they are streaming live on the YouTube as well. So if someone misses some part of the video due to poor connectivity, or if there is something which may come up urgently, you can definitely visit our YouTube channel and search for this particular OTP. Day-wise, we have a separate link, and we stream it live day-wise. So every day there would be a link which is posted on the YouTube to watch the proceedings live on the channel. So moving on now, with Madan Mohanji with us, I would also like to quickly check. There are certain questions which we'll be taking up, Madanji. There are
Sir.
questions from, based on your interesting presentation. I see a series of questions. I would have, had there been a speaker after you, I would have requested you to answer them on the window. But now I have this opportunity that I can ask you these questions live. And one of
Yes,
the
sir.
first
My
questions
pleasure.
you mentioned about corrosion, and there's a relevant question from Muhammad Faris. Does moisture gases cause corrosion of the internal part of the pipeline?
Yes, sir. See, when a gas is produced at the wellhead, it contains lots of impurities like H2S, moisture, carbon dioxide, and other gases. before we put in the gas in our pipeline, it is stripped of all these impurities. But still, to certain extent, say in parts per million, some
Mhm.
type of impurities they do happen in our pipeline. They do get entry through a production wellhead. So all these impurities, if there is presence of moisture, they can form a corrosive substance like acids. H2S will form sulfuric acid, CO2 will form carbolic acid, and these acids in very small quantities, although they do react with the base material. The pipeline is made of carbon steel, and these acids they corrode our pipeline. See, thickness is not much, 6.4 mm. If you compare it with other structural steels, it is very less. So 6.4 mm thickness, if over a period of time it gets reduced due to these corrosive substance, we can have a failure at that point, or we have to replace that pipeline. It can lead to a very catastrophic event.
Yes. Oh, thank you. Thank you for throwing light on that. There was a concern from Mr. Pramod Parekh, who's a very active participant of our OTPs. And he has a list of questions also for you, Madanji.
Yes.
In fact, there were certain patches on the. He says that there were certain rectangular patches on during the presentation when it was streamed. But I'm sure on the YouTube, if it's not there, if there is still some problem in reading one of these.
Yeah,
Uh,
I think
uh,
this is due to network issues at my end, probably.
That's no problem. We'll have a copy of the share what you can share with the participants, and if there's something, we'll
Yeah,
post
sure,
it online for them to
sure,
have a
sure.
look again. There's a question from him, Pramod Parekh. Is there any plan of blending hydrogen in natural gas distribution pipelines, as being done up to 5 to 10%, with the purpose of reducing CO2 emission, as H2 is a cleaner fuel as part to achieve climate change targets? What are the risks assessed, if any?
So
Yes.
at present, we do not see that we can add any type of such gases in our pipeline.
Okay.
As to hydrogen is very dangerous. If it escapes to
Yes.
atmosphere, that can cause the
Absolutely. Havoc.
catastrophe unknown measures. So we cannot take
Havoc.
this risk.
Yes. Thank you. Sometimes we face requests from oil and gas industries during ERDMP mock drills.
Yeah.
They insist to accept scenarios of theirs, which we do not accept. We give a scenario and according. So basically, this question is, when ARDMP related mock drills are held,
Hmm.
are there any restrictions to the sort of scenarios which can be determined, or even the extreme scenarios can be taken up in mock drills for ENDMP?
So see, for conducting any mock drill outside our plant premises, we have to get the permission from district authorities, and district administration they take the lead in organizing such type of drills.
Hmm.
So we are basically driven from their end. We cannot force them to use our scenarios or what suits our requirement. We'll like to have all sort of worst case scenarios so that we get a hands-on training to mitigate or handle those sort of emergencies. But at times, district administration, you can understand, they are also overloaded with their administrative jobs. So
Mhm.
this is sort of lacuna we are having in the system.
Okay. There's a question from Mr. Huck. Yeah, what is the benefit of PIMS in safety?
Yeah, actually, PIMS is a software-based approach.
Mhm.
We take the help of softwares to assimilate and assess all type of data and compare it with historical data, and it can be used to predict risk and occurrences of failures or chances of failures, and it can also provide us an insight that we have to take any entry measures, like for example we get data from inline inspection, so it tells us about what is the my present condition of the pipeline, what is the thickness loss. So this data we can compare it after 5 years when we again run the intelligent pig. So based on these two segment of data, the software model, it can predict that your corrosion or thickness loss is happening at this rate, and going by that rate, what is the chances of failure, what is the chances or what is the timeline of reaching to that extent where your pipeline can fail at this pressure or operating condition. So this computer based modeling is only to help us plan a lot of mitigative actions. So this
Yes.
is an aid in proper safety planning of the pipeline assets.
It's a question from Pramod Parekh about the SIS design. He says, has this subject of SIS design identified in for educating process safety designers and managers of future hazardous industries, including chemical, pharma, agro, fertilizers?
Sir, this process safety, it's a very vast subject. So it is
Absolutely.
already touched upon by Dr. Gupta. It
Yes.
needs to
So,
be, yes, all the
so I think,
industry as well as academia, they have to come together, and this process safety aspect need to be taught to all graduates who
hmm,
are going to join oil and gas industry or any other chemical or allied industries. It's a very good
hmm.
subject. So at present, I think I'll not be able to answer this question clearly because
So that's all right.
this is a vast subject, and
Vast subject,
yeah,
and it's an evolving subject also. I
yes.
think this is one of those evolving subjects of the industry. Um, Dilip, Vasu asked an interesting question because we talked about laying of pipelines and how this network is ever expanding uh, in our country. Have you ever come across a scenario where nearby structure or a building collapsed during the pipeline laying activity, or any damage to the structures? And what are the best practices to follow to avoid such kind of emergencies or lapses during excavations to lay the pipelines? Please share some thoughts on this.
Yes, sir.
Dilip Vasu asks.
This is a very good question. Sir,
Yeah.
before we lay any pipeline, we carry out a detailed route analysis. We carry out the feasibility of that route. It depends on lots of factors. We do get a map of the area. We do get a topography survey done. We do get a listing of all the structure or vulnerable location which may come across our pipelines. So we deliberately avoid all such areas. We try to lay a pipeline which causes least trouble to already existing structure or habitats or flora fauna on the land. So there are very less chances of encountering such type of problems where due to our construction activities in pipeline any damage is there. We do get certain type of like if we lay our pipeline through farm areas, we sometimes we have to this not damage, we have to remove the bore wells or other small structures for which we adequately compensate the owner. So there is very less chance of any accident occurring in the
Yeah.
construction of the pipeline.
Yeah.
And
And
whatever damage we do, we rehabilitate or we compensate the affected person.
yes, I mean that's the beauty of the modernization of the entire process of industrialization, is that that is something, a responsibility which it usually
Yes,
used
yes,
to be
rightly
administration,
said,
but
sir.
now it is the company itself. It could be a PSU or a private company which makes sure that during the expansion work or during the networking, expanding the network of anything for
Yes,
that matter, not only pipelines, but even for any sort of infrastructure, any public infrastructure, they take due responsibility of rehabilitating to making sure that the anything which gets affected is left in the same condition as it was earlier. And
yes, and we take pride that we are a very responsible organization.
yes, yes,
We
yes.
cannot afford to have such public image that we go on destructing the already uh, existing properties.
And I think this also comes from maintaining that corporate reputation, which we were talking
Yes,
about earlier, which I also briefly mentioned. that health, illness, safety, security is definitely one aspect of, or different aspects, or many aspects of industrial safety overall. But I think the corporate reputation and the public relations is also equally important in the entire process, because
Yes,
in
yes,
this
yes. Rightly
competitive
said, sir.
world, I'm sure even an engineer who's working at the shop floor level, during his training, he's told that, how he should, as an individual or an employee of a company, should take that responsibility or that mantle of improving the corporate reputation of also of the company, which
Yes,
is,
yes,
as
yes.
important as conducting his day-to-day duties. I think this is a
Yes.
cultural change which has come in the way, and pleasantly so, in the way the public sector units, or the public sector undertakings operate. And I think huge difference and huge professionalism, which has, it was always very professional, but it has become more, I would say, in line with the international best practices, even the Indian PSUs. And I think that is a great moment of, it's a matter of pride for all of us as Indians. Thank you so much, Madanji, for that
Thank you,
input.
sir.
What
Thank you.
will be the possible reasons or scenario of fire at a minor leakage point in an underground propane line where evidence of corrosion is evident? This comes from Hemant Bish.
Sir, for any accident to happen, there have to be three causes. First is
Mhm.
substance, which is maybe gas or any other inflammable substance. Another one is oxygen, and third one is presence of fire igniting material, fire or any spark.
Yeah,
So
yeah.
unless these three are combined, there are very less chances of any explosion or fire happening.
Mm-hmm.
So, and further, in the case of gases, for any explosion to happen, it has to cross a threshold level, that is lower explosive limits. Then only it can ignite to such an extent that it can cause any explosion. So we do not find such type of scenarios happening normally, like where your pipeline is going underground and you observe a minor leakage and there is a sudden explosion.
Yeah, yeah,
There will
yeah.
always be some mitigation measures based on visual inspection or through use of certain techniques. We do get to know whether any substance is leaking from my pipeline or my assets, and based on that, we carry out the mitigation action.
Yes. In fact, one of the questions which was asked, I'm just trying to find, I read that earlier, about the the how far can the welding of can be done around the pipelines, all of that. One of the very key achievements, I would say, of our forum was, FICCI does commercialization of technologies for DRDO and for Department of Science and Technology. One of the
Mm,
technologies developed by DRDO scientists was
mm.
QT alloy, copper titanium alloy. Now that is apparently supposed to be safer while
Yes,
welding, because it's a non-sparking tool. So
yes,
one
yes,
of the through our process of commercializing technologies, one of the organizations called Pawa Matiltech, who gentleman was working with one of the corporates in India, left his job, and along with his son acquired this technology and commercialized it. Today,
yeah,
the same, when the tools which he makes, so for two, it could be a tool from maybe a screw to a big hammer, or any tool which is used in industries. It's a non-sparking tool, and he recently supplied the same material. And CIDM was the first platform where he made a public presentation or launched his product.
yes.
And
Yeah, I
today,
was there in Hyderabad, I think.
yes. And today he recently supplied successfully to a government order in Sri Lanka,
Oh, that's great.
last week. So, and apart from supplying to Africa and even in European countries, in CIS countries. So, I think with the technological intervention and innovation, constant innovation happening in the area of industrial safety, I think that is something we also encourage and promote young minds, scientists in the academic structure. That is why we encourage people from, students from IITs and other technical institutes to participate in these OTPs, and they know where the problem lies. See, because knowing the problem is the key to a successful solution or to an
Yes.
innovation.
Yes.
I think defining a problem statement, and here people like
That solves the problem halfway.
halfway. So we're really proud that we can facilitate that sort of a dialogue also, where young minds, young professionals. Even he was a this guy, Mr. Pava. He was, he had a 30-year ongoing career with one of the corporates, and he thought that this was the problem which he needs to solve. He had the
Yes.
technology, he acquired that, and today doing great business. So this is a motivation for a lot of young entrepreneurs, technical brains, to look into this area, because industrial safety and disaster risk management overall, the disaster risk reduction or the disaster risk management overall, comes with a huge business opportunity angle as well.
Yes.
It
Yes.
has been
Definitely.
untapped. It has been untapped for years together, and I think whatever business has been tapped is been done in bits and pieces. But now is the time, and I think COVID has also provided that time, that where people are looking for other options of to innovate, to other forms of livelihood as well. How they could come out of a working culture to become an entrepreneur. I think this is one area which provides a lot of opportunity, business opportunities, from training, from skill development, from equipments, from it could be detectors and all of that, and everything has the potential, and a lot of things the industry needs them, and I think the industry also needs the right solutions, which I think the innovations will sort of fill up.
Yes. Definitely, sir.
Last couple of questions before we end today's
Sure.
OTP. Um, what is the precautions for laying pipelines for underground diesel storage tank laid in chemical industries? If you have any idea, this is a question from Vinod B.
Diesel storage.
Yeah, I think diesel storage, and I think transporting diesel within the industry through pipelines. Is there any
Uh,
in industries?
As a thumb rule, we follow all the precautions like we bury it to the depth of around 1 to 1.5 meters. We
Hmm.
coat it with 3-layer polyethylene coating before we bury the pipeline underground. We follow the
Uh-huh.
best safety practices or best construction practices like welding, then selection of material. Then, of course, if we are transporting diesel, we do try to coat it internally so that it does not cause any type of corrosion or chemical reaction in the pipeline. So these are
Mhm.
basic thumb rules for any pipeline, whether it is pipeline, crude oil, or natural gas line, or any product line.
Okay. The final question, Mr. Madhumohan, I have saved this question for the last.
Yeah.
This comes from me. I just
Okay.
want to know your inputs or your feedback or your reaction on the Oil India burst, or the incident which has happened in Tinsukia, Assam. A lot of audience of our participants are also keen to know what is your take, and what is the government doing, and how you think that can be, when will this incident end? Is there any picture from a professional point of view?
Sir, speaking about any other company will be unethical for me, but at
Yeah,
the same
yeah,
time,
yeah,
I would like to talk about our own experience.
yeah.
See, as we already know, GAIL has had its own Black Swan incident that happened around 6.5 years back in
Yeah.
June 2014, where in
14.
Kakinada district we had a very catastrophic pipeline failure.
Yes.
So, analyzing what happened, what caused this incident, we came to know that the extent of internal corrosion or the chemical reaction happening in a pipeline due to ingress of impurities like CO2, S2S, and moisture, what trouble it can give us. We came to know due to that incident, and after that incident, we came back as more resilient. We came back as more knowledgeable company about the dangers and mitigation measures we have to take to avoid such type of catastrophe in the future. We have had our policies and procedures and SOPs redefined, and we took help from international experts. We carried out industry meets in the field of corrosion management. We had our very own series of corrosion conference with the help of corrosion, see this Corcon, NACE. So
Mhm.
so we can say that today, after 6.5 years, we stand at a place where we can guide other members on this aspect, as well as we have built a capability and we have built a robust system that such type of failures will never happen again in the uh, future life of the company. This I can.
Thank you. Thank you. I can't help but take this one last question, Madanji, and then we will say a formal thank you to you. A
Sure.
question from Shiva Shankar. He says, is the biological gases evolving from Earth around the pipeline causing most corrosive effects on pipelines? What is the effect of methane gas and other gases like sulfur, etc., on existing pipelines and how to address them? Shiv Shankar
Yes,
asks.
it's a good question,
Very good
but
question.
but
Yes.
it's a hypothetical case only. But although these type of corrosive gases, unless my pipeline is exposed to such gases,
Yeah.
it will not cause any effect because I protect my pipeline through 3-layer polyethylene coating. Then I carry out impressed current cathodic protection. We carry out daily patrolling, monthly patrolling. By monthly patrolling through helicopters, we carry out all sort of leakage surveys. So the chances of encountering such type of troubles, it's very remote. It's very remote.
So, how, Madanji, what is the lifespan of an operational or of once it is installed? What is the lifespan of a pipeline
Sir, another
usually?
good question, sir. If we maintain
And
our
it comes from
pipelines,
Mr. Mohammed Mishal. So,
yeah,
last question, yes.
if we maintain our pipeline with all the precautions or whatever methods we have talked about in the presentation, the pipeline life is indefinite. It can
Oh,
go as long as possible. See,
okay.
the very first pipeline of natural gas which we laid in 1984, it is still running as good as new.
Oh,
So
wonderful.
we take pride that we have maintained our systems and pipelines in such a manner that it is as good as new. We have
Fantastic.
been carrying out all those these surveys and integrity assessments, and we
Mhm,
have come out with the finding that our pipelines, our procedures are excellent, and
mhm, mhm.
we are trying to improve. We are trying to match with global best practices also, so that we can further improve our practices.
Right. On that note, the questions keep coming in, but sir, we have limitation of time. We've taken a lot of your time, Mr. Madan Mohan. Thank you so much
Thank you,
for
sir.
very patiently answering each and every question and very diligently answering them as well. I
My
think
pleasure, sir.
on behalf of all the participants, I must like to thank you, and I would like to thank you, in fact, for all your time, your brilliant and beautifully compiled presentation. There are questions which were targeted to Sri Anil, Professor Anil Gupta. He had another online meeting with the ministry, but he has assured me that he would come back either tomorrow or day after to take up those questions which were related to his presentation. And I would, Harshit is here, so Harshit will endorse that view that he has promised that he would come back, in one of the 2 days to answer those questions. So participants, I think you've been very patient. And I think, I hope, at the third day, we would also share a feedback link with the participants for their crucial feedback, because we are as good as the feedback we get. The OTP is as good as the feedback we get from the participants. They define. They have the final, I would say to the quality and to the organization of these OTPs what we present. I think we had a good first successful day. Thanks to our two very eminent speakers, Mr. Madan Mohan. We look forward to having and seeing more of you, sir, in future. I think
My pleasure, sir. My pleasure.
we are very happy, CIDM, on behalf of my chairman, General Bhardwaj, our board members, which include Dr. Muzaffar Ahmad, who is a former member of NDMA, Mr. Labendu Mansingh, uh, former founding chairperson of PNGRB, Mr. Rajeshwar Rao, who is the additional secretary and senior advisor in the Economic Advisory Council to the Prime Minister, and with blessings of late Shri S. Krishnan, who's the also a former who was the former chairperson of PNGRB. I think with these great minds, and he continues to bless us from up there. It's been great working with these beautiful and these intelligent minds, and they've helped us compile this program together, and they continue to support us. Thank you again to Major General M.K. Bindal from NIDM, the Executive Director, Professor Anil Kumar Gupta, Head ER DMS at NIDM, Harshit, thank you to you and to Dr. Anjali. Special thanks to our colleague, my colleague Akhil Gupta, Sanjeev Kumar, Menak Majumdar, and Varun Sharma. I would also like to make a brief announcement that FICCI's annual general meeting is being scheduled on the 11th, 12th, and the 14th of December. Honorable Prime Minister of India, Shri Narendra Modi, would be inaugurating our annual general meeting and the annual convention, which would be on the 12th. He would be formally inaugurating it. It's a very interesting 3 days of business convention which will be held, and I encourage industries and academia and participants here present to join us there at the AGM as well. It's a very true reflection of what the government thinks. You will get a true reflection of how the government is planning, what the policies are looking up to in times to come, when we are trying to come out of this challenge of COVID crisis. Prime Minister Modi will be addressing the audience. It's an online event, so we look forward to participation from all. We, in fact, very interestingly, will be also an exhibition which would be launched on the 11th of December. An exhibition which will go on for 1 year. So anyone who participates, who logs on to as an exhibitor, will be there on the online platform for 1 year. So, and we are trying to create an exchange of business, a B2B exchange where active business can keep happening 24/7, 365 days. So we'll share links in next couple of days of how you can access that annual general meeting. So on that note, I will say bye-bye to everyone, and with the hope that we all meet tomorrow again at the same time as we started today, for another series of presentations by eminent speakers, Dr. Jugal Kishore from Safdarjung Hospital, Dr. Sunil Pandey from TERI, and Dr. Ashish Mittal from Occupational Health and Safety Management Consultancy Service. On that note, thank you again, Mr. Madan Mohan, and
Thank you, sir.
thank you all the participants. We look forward to seeing you tomorrow. Thank you, the organizing team of FICCI and NIDM, for putting a great effort together. Thank you. Bye-bye.
Thank you.
See you tomorrow. Bye. Sandeep, I think we can be done for today, right?
Yeah, we are done for the day. But tomorrow same time we'll be again joining.
2:30, right?
Yeah.
So, I think we made the important announcements for all the participants. If there is anything we have missed, we can probably show it as the first slide tomorrow. We can discuss internally with Akhil if there is any slide of do's and some important pointers, so that the presenters can. Dr. Ashish Mittalji, thank you so much for joining us today, sir. We look forward to your presentation tomorrow afternoon. We start at 2:30 and we end almost at the same time. So good.
Same time.
We have started on time and we have finished bang at 5 o'clock. So okay. On that note, bye-bye, Sanjeev. Bye-bye, everyone. Thank you, Arun.
Thank you so much. Thank you so much.
Bye-bye. Bye bye. Let's talk offline. Bye bye. Thank you.
Yeah, sure. Bye.